Well, good morning, my dear students. Welcome to the today's session. The today's session is related to the revision of Module 2, both the bolted connections and also the welded connections. Just I'll quickly the follow through all the slides. Okay, then we'll try to solve one or two problems, and we will make this the revision of the Module 2. And you have seen normally the bolt is the metal pin with head at one end. So this is your head at one end. A shank threaded at other end. See, this is the shank. Okay, this is what is the shank, and this is what is the threaded. This is the threaded portion. Okay, this is your net portion, and other end to receive a net. Okay, as shown in the figure 4. Okay, this is the bolt what we have normally we will use. Okay, this is the bolt. Now there are three types of bolts are there: black bolts, finished or turned or fitted bolts, or third one is high strength friction grip bolts. Black bolts are the unfinished bolts and are made up of mild steel. Normally they have square and hexagonal head. The diameter is 12, 16, 20, 20, 22, 24, 27, 30. Okay, these are the diameter of the bolts what you will see. And these bolts does not establish any contact between the structural member and the contact area of the shank as they are unfinished. Used for light structures, temporary conditions. Okay, these black bolts normally they are used whenever the light structure is there. Temporary corrections whenever we require for the erection. Okay, the grade is normally what 4.6 grade. The next is finished bolts or turned and fitted bolts. The turned and fitted bolts are also made up of mild steel but have the uniform shanks. The previous one is non-uniform because it is unfinished, but here it is little bit finished. It is having what a uniform shank and are inserted in closed tolerance to drilled bolts. So there is some tolerance whenever we are using this bolt. But under dynamic load, okay, these the nuts are liable to become loose. Whenever there is a dynamic load, the net will get what is loose. Therefore, normally we will not use these bolts under the dynamic loading. However, due to the low cost of bolt, its installation, okay, its cost is low and its installation cost also it's low. Okay, normally this black bolt, okay, it is quite popular in simple structure subjected to what is static loading. Whenever you have a static loading with simple structure, normally you can go for what is you can go for this finished bolts. And these bolts are available from grade 4.6 to grade 6.8. Then the third one type is high strength friction grip bolts. These are the bolts are made from quenched and tempered alloy steels with a grade from 8.8 to 12.9. The most common so-called are called as 8.8. Normally, most of the times we use 8.8. These bolts should be tightened to their proof loads. Okay, before we need to tighten the bolt water proof loads, and this will require a washer to distribute water load under the bolt heads. The tension in the bolt ensures that no slip takes place. Okay, because of the pre-tensioning in the bolt. Okay, therefore there is no slip in this type of bolts under the working load condition. The load transmission from plate to the bolt is through friction and not by the bearing. Okay, this we will see in the coming slide diagrams. However, under ultimate load, the friction may be overcome leading to a slip, and so bearing will go on the result. These things you will see in the upcoming slide. These are the three types of the bolts. Normally in the examination, okay, you will ask at least one or two types of the bolts with explanation. Now here, whenever you want to transfer a load, see this is related to your the SFG board. See this, whatever these forces are there. Okay, this is what is the clamping forces. Okay, and here below this, here you will have what is the friction forces. This here the load is transferred due to what is your friction force. But in HSFG bolt, but whereas in finished bolt, okay, in finished bolt, it is transferred by these bearing stresses. Okay, this is related to what is finished bolts. This is the main difference. Okay, the main difference between what is the finished bolt and also the HSFG bolt or black bolt or and HSFG bolt. The advantages and disadvantages of HSFG bolt. Advantages: the as it is we are applying a pre-tension to the bolt. It is quite rigid. There is no slip takes place. Okay, as load transfer to the friction. Because of friction transferring load, there is no slip takes place. Bolts are not subjected to shearing and bearing stress. High strength nuts are prevented from loosening and stress concentration. Okay, because of the high strength, okay, these are the some advantages. Disadvantages: the material cost is high. Another one is it requires a skilled labor because you need to apply a pre-tension to the bolt before application the load. Hence, okay, it requires what is the skilled labor. These are the some advantages and disadvantages of the your HSFG bolt. And these are the classification of bolted sections. Okay, this is a concentric connection. See here where all the lines, okay, they are all the lines they are meeting at the one point. Okay, this type of connections is called as what is the concentric connections. Here you can see this is also the the angle section. Okay, here also you have your here this is your angle section. This is your ISA angle section. See, this is the green color plate is what here. This is your gusset plate. Okay, and here bottom it is the stress member. Okay, it is like this where when all the lines are connected to a single point, it is called as what a concentric connection. And here this is called as moment connection. Whenever the connection it is connected like this, okay, it is the 3D view, but whereas this is what a your the line diagram of the this connection. This is called as moment connection. And this is the lap connection. Most of the times you will see this one. Okay, one plate above the other plate. Okay, this is what is there is only the single lap is there. That is why it's called as single bolted lap joint. There is one bolt with single lap, and here it is called what there are two bolts are there. That's a double bolted lap joint. Okay, in the plan it looks like this. Single bolted it looks like this. The double bolted it looks like this. Butt joint, we know whenever the butt joint means we will face the two plates face to face. See, this is one plate, this is one plate, they are connected from face to face. Okay, we will use one extra the cover plate to connect what is these two plates. Okay, if you are using a single cover plate, it is what is single cover butt joint. If you are using a two cover plates to join these two plates, it is called as what is double cover butt joint. Okay, this is your the isometric view of your section. Okay, these are the main two plates which we want to connect, and this is what is your cover plate. Okay, here single cover plate, here two cover plates. Depend upon this is single cover joint, single double cover joint, like this. This already we have seen the bearing stress. Okay, the your stress is transferred by bearing. Okay, those type of sections are called as the bearing type sections. Whenever the force is transferred by the friction, these are called as what is the friction type sections. In your IS 800, okay, there are two types of bolts. One is friction bearing type, other one is what is the friction type. And these are the failures. Okay, you can see whenever this type of failure will occur, this is called as what is the shear failure of the bolt. Okay, but whenever if you see this type of failure where the cross section is the reduced, okay, here it is cutted, but here it is what is some amount of cut is reduced. This is called as what is the bearing failure of the bolts. Okay, this is the real structure what you can see here. Okay, this is you can see this type of failure is called shear failure, whereas this type of failure is called as what shear failure, bearing failure. So then this is a basic nomenclature. You know the distance between two bolts along the direction of the load. Okay, it is called as pitch P. Okay, the distance between the two line of the bolts, it is called as the gauge distance G. The distance between the center of the bolt hole to the your what you call to the your this end of the plate. Okay, this one. Okay, to the end of the element plate, it is what the E dash. Okay, normally it is called as your end distance, and this is what the distance between from center of bolt hole to the end plate. Okay, this is called what E. Okay, this is the all basic terminology. Normally, what this is required. Okay, this is the edge distance. Okay, from center of bolt hole to the up to this your adjacent edge. This is what this is your edge distance. This is your what end distance. And these are the what is minimum pitch, maximum pitch. Minimum pitch is 2.5 times of the diameter of the bolt. Maximum pitch is 16t or 200 mm, whichever is less for tension member, where t is the thickness of thinner plate. But in case of compression member, it is 12 into t or 200, whichever is less for compression member. Okay, in case of staggered pitch, whenever you arrange the bolts in staggered fashion, then pitch may increase it to 50% of values as specified above. Okay, provided your gauge distance is what less than 75 mm. Okay, this is the then this is maximum pitch. Maximum pitch shall not exceed 4.5 times of t. Okay, for a distance equal to what 1.5 times of t. And this is the gauge distance. Maximum is 100 plus 40 or 200 mm, whichever is lesser. For edge distance, 1.7 times of dh is a minimum edge distance. 1.5 times of dh depend upon the whether it's a hand flame or the machine cut edge. Okay, these are the two minimum values. The maximum is one is 16 times of t into epsilon, where epsilon is square root of 250 by fi. T is the thickness of thinner outplate. Okay, another one is 40 plus 40. Okay, where it is out of these values you need to take what is the lesser value. And normally we will see that the bolt is represented by M12, M20, M30, where this number will indicate the diameter of the bolt. Okay, this will indicate what is diameter of the bolt, and your diameter of your hole is the bolt hole is equal to what? The DH is equal to the diameter of bolt plus clearance, and this clearance you can see from table number 19 of page number 73 IS 800 2007. Okay, this is your here depend upon the your diameter of bolt. If the bolt is from 12 to 14 mm, then clearance is 1. Okay, if it is 16 to 22, the clearance is 2. If it is 20 24, it is 2. If it is larger than 24, it is 3. In this way, we have to choose the clearance to calculate what is the bolt hole diameter. Now normally the bolt is indicated by sometimes M20, a bolt of M20 with property normally will get in the question. Okay, if the grade is 4.8 means, okay, then here M20 means 20 will indicate the nominal diameter. But whereas its ultimate stress, okay, this you can get from your table number 1, page number 30. See here it is class 4.8. Here you can see the grade or classification 4.8. For 4.8, what is the ultimate stress? Ultimate stress is how much? 420. Okay, therefore this is how much? This is 420. Okay, and this your value you have to the ultimate stress FE value you need to get from area table number 1. Okay, in this way you can use your table number 1. Okay, these are the some basic things what we need to remember in the bolt connections. But okay, these are the things what we should keep it in mind. Okay, before we are going to calculate the strength of the bolt or bolt value. Okay, in the numerical problems. But when it come to the welded connection, when you come to the welded connection, okay, most of you have seen this type of welding you will make. Okay, it is a process of joining a two metal pieces by creating a strong metallurgical bond between them by heating or pressure or both sometimes. Okay, this is the welding what we are normally observe. Now there are once again here also there are three types of welds generally: butt weld, fillet weld, salt weld, plug weld. Okay, first is the butt welding. Okay, whenever the butt welding is there, they are face-to-face connections. All are, but once again in the butt weld, okay, by here there are the n number of types. First one, the square butt weld in one side. This is the square butt weld in one side. Square butt weld two side. Okay, this is two side here. And single V joint, single V joint. Okay, sometimes it is also called as incomplete penetration because this welding is not done to the complete depth, and it is a double V joint where the welding is done for complete depth. This is called as complete penetration. Okay, single U, single J joint, and single bale joint. Okay, these are the some different types of the butt welding. Okay, so different butt welding depend upon the requirement. And second one is the fillet welding. Whenever we are welding a two metal with some angle, okay, joining a two the pieces of two metal together, okay, whether by perpendicular or at any angle. Now here we are joined by perpendicular. The welds are commonly referred as T joints, which are two pieces of metal perpendicular to each other. Okay, this is called as what is the T joint. Okay, because these two plates are joined by by this welding, okay, at 90 degree. And here this is called as what is, this is called as the leg size. Okay, these two things are called as what is the leg size. Okay, these are called as leg size. And here also whenever you will use the lap joint, okay, this is called what a lap joint, when the two metal pieces are overlap and when they are welded like this. Okay, here also this is what is the your leg size. Okay, these once again the types of fillet welds. One is concave, means whenever your shape is like this. This is convex. Okay, this is what is the miter. Okay, depend upon this here also. But here this leg is called as what here, yes means the size of weld, and whereas this perpendicular distance, okay, this is called as what here, the throat thickness. This is your salt and plug welding. Okay, this is a salt weld. Okay, you will make a circular hole. Okay, and around the circle periphery, around the periphery of the element. Okay, you can see here around the periphery of this. Okay, this hatched portion. Here you are making what here, the welding. This is called as what here, the salt welding. And here also you will make in plug weld. Here also you will make a circle, but instead of along the periphery, the entire thing is what here, it is welded. Okay, this is what is the plug welding. These are the important types of your weld. And in the weld, the another one important portion normally what we'll see in the examination, the defects. What are the different types of the defects? Okay, this already we have seen: incomplete fusion, porosity, inadequate preparation, undercutting whenever the excessive current is there, slag inclusion. Okay, failure to remove slag between this. Okay, we are unable to remove this. All this we have discussed in the class. Okay, the cracks normally will get, and okay, sometimes you'll get the lamellar train. Okay, these are the some welded defects. Okay, most probably, okay, this question they will ask in examination. Okay, along with these diagrams, okay, you need to explain around some 3 to 4 line 4 points. Then advantages, disadvantages of weld. The, okay, the erection of structures is speeded up. Okay, but the another one thing is the welding enables direct transfer of stress between the members, eliminating the gusseted splice plate. The most important, the advantage of going for welding is what? Okay, here you can remove the use of what? The gusset plate. Because if you have seen in the previous diagram, whenever you want to join 3 or 4 plates, okay, we are using what? Gusset plate. Okay, but now because of this welding, okay, most of the time we can remove what is this gusset plate or the splice plates. Okay, this is the main reason, okay, which made to shift from what is bolted to the welded connection. And hence the because of this, whenever you remove the gusset plate or splice plate, okay, hence the weight will become what is less. This is the most important advantage. In case of tension member, absence of holes will improve the efficiency of section. Because whenever there are no bolt holes are there, automatically the stress concentration will be less, and ultimately the strength or efficiency will get what is increase. And this involves the less fabrication cost. Okay, because there is no drilling of holes, nothing like this. Okay, that's why it involves what is the less less fabrication cost, and less labor leading to economy. Obviously, it requires a less labor. It is a airtight and watertight joining. It will not get any problem due to the air and water. Okay, as compared to the bolts. Another one is it is a neat appearance for the complicated shapes. It is more rigid connection. You can go for truly continuous structure, and these welded joints are strong as compared to your the any other joint. And stress concentration already told it should be considerably it is less. These are the some the advantages of your what is the welded correction. And disadvantage, the first is it requires a skilled labor. Okay, it requires a skilled manpower for welding as well as for inspection. And the non-destructive evaluation may have to be carried out to detect the defects in welding. It's very the uncongestive process to detect what defects in the welds. Only you can do what the non-destructive test. Okay, we can't detect directly. Welding in the field may be difficult due to the location and environment. Okay, on-site welding it is different. Okay, it is little bit difficult as compared to the bolting because we want the power, everything we want. Welded joints are highly prone to the cracking under the fatigue loading. Whenever you have a cyclic loading, okay, it is subjected to what it is cracking, and sometimes the large the due to the your welded defects, you will have the large residual stress and also what a distortion, okay, which were developed in the welded connection. Okay, these are the advantages and disadvantages of what the bolted connections. Sorry, welded connections. Now we will go for the some specifications. Whenever what main important is how we need to find the size of the weld. Okay, the minimum size of the weld, any type of weld is what 3 mm. The maximum size is, if the connection is like this, the size of the weld is equal to thickness of the plate minus 1.5 mm. But whenever you are joining your what the toe part, your angle section, okay, in that times your thickness is equal to what 3 by 4 times of thickness of the plate. And next, what we can do, how we need to calculate strength of the weld. Strength of the weld, FWD is equal to FWN divided by gamma MW. FWN is equal to FU divided by square root of 3. Okay, smaller of ultimate stress of the weld of parent metal, very FU, and it is partial safety factor from table number 5. You need to use these formulas to calculate what a weld strength. Okay, and whenever you are using a fillet weld, same formula, strength of the weld will remain same, but only thing is if you multiply this strength, okay, this strength means this F is stress, this stress into area. Area is what? The length of the weld, okay, the length of the weld multiplied by thickness of the weld. If you multiply area and stress, here you will get what is the force, okay, or the strength of the weld. If you multiply stress into area, you will get what is the strength of the weld, that is what is FWD. And normally throat thickness generally we take it as what a 0.7 times of S, and this S is depend upon the angle between these two, whether it is a 30 degree or 40 degree. We have one table. By referring one table in IS code, we define what is this S value. Same formula, but whenever it is a butt weld, your throat thickness is equal to what? 5.5 by 8 times of thickness of thinner plate. Okay, whenever it is here, you can see it is a single V joint. Okay, and if it is this is the double V joint, then your throat thickness is equal to what? Thickness of the throat or thickness of the thinner plate. These things you need to keep it in mind. All the things are there in page number 78 and 79. Okay, otherwise you can go and see them. Another one important point is whenever the length of the welded joint, okay, if an end connection is in compression or tension element, if it is greater than 150 times of the throat thickness, then the design capacity, your FWD, shall be reduced by a factor. Okay, this is the factor what we need to use. Okay, by substituting LJ and LD, this fact by using this factor, you need to reduce your water FWD. These are the some important points you need to keep it in mind with respect to what is the welded section. Okay, now we will move to see the one welded problem and one bolted problem. Design the following joints using design the following joints using a ordinary black bolts between the two plates of width 200 mm and thickness 10 mm, 18 mm respectively. Width is 200 mm but thickness is different. One is 10 mm, the one is 18 mm to transmit a factored load of 150 kilonewton. Okay, this is the question what is asked. Now here you have to do single lap joint. You have to go for single cover butt joint with cover plate of 8 mm, double cover butt joint with 8 mm cover plates. Okay, for these three things we need to design, and here he has given use the plates made up of Fe410 grade steel and also 16 mm diameter bolt of grade 4.6. It is the given data. Now first diameter he has given. Okay, diameter is how much? 16 mm he has given. Okay, and 16 mm. Whenever it is a 16 mm, your clearance is how much? 2 mm. 16 plus 2, it will give you what? The bolt hole diameter, that is how much? 18 mm. Okay, and this your bolt, this clearance will get from here, table number 19. For grade 4.6 bolt, your FUB is equal to how much? 400 MPa. This is from table number 1. For Fe410 grade of steel, your FU is equal to what? 410 MPa. This is, and gamma MB from table number 5, it is how much? 1.25. Now if you go for the lap joint, first this is a lap joint. Okay, the most important is we need to decide how many failures are there. Okay, now here there are only the one failure in the shape. Okay, therefore assuming the threads in the shear plane, okay, this failure has occurred in the threads. Okay, therefore here Nn is equal to 1 and Ns is equal to what? 0. Okay, if the failure is there in your threads, then the Nn will become 1. Otherwise, if the failure is there in shank, this Ns will become 1. This we need to assume. But here I have taken the failure in the thread, it has what? The 1. Then for 16 mm bolt, you need to calculate A and MB. A and MB is equal to what? 0.78 times of pi by 4 into d square. Substitute the values, you will get 157 mm square. And you know that the design shear strength, your formula Fu divided by FUB divided by square root of 3 gamma MB Nn A and B plus Ns into ASB. As Nn is 1, Ns is 0, this will become what? 0. If you substitute these values, okay, you know here, you will get this as how much? 29 kilonewton. And to calculate next the strength due to bearing, okay, the formula is what? 2.5 kb dt Fu divided by gamma mb. Okay, now here if you want to calculate kb, okay, you have the formulas in your code book. Okay, around there are 4 formulas are there. Okay, E by 3d, P by 3d. Okay, their formulas are there. By substituting those formulas, okay, here also one formula is there: E divided by 3 into d, P divided by 3 into d minus 0.25, Fu divided by FUB. Okay, and this is what? 1. Out of these 4 values, your lowest value will be what? 0.7. Okay, but this E value, P value, you need to calculate by minimum pitch. The minimum pitch is equal to 2.5 times of d. D is 16 mm, diameter of bolt, you will get what? 40 mm. The minimum end distance E is equal to 1.5 times of D. You are getting this as what? 27 mm. And there are two formulas. One is 1.75 times of D, other one is 1.7 times of D. Okay, one you will get 27, other you will get it as 30.6. But here I have taken as what is 31. And pitch I have taken as, even though I got 40, but here I have provided how much? 50 mm. Okay, these values you need to substitute for calculation of what is the kb value, and you will get, if you get the kb, the formula is 2.5 kb. You know, out of these values the lowest value, is 0.57, and d is equal to diameter of bolt 16 mm, t is equal to thickness of the plate. Okay, that is how much? 10 mm. Out of two the plates, you need to take the lesser value 10 mm. Fu is the strength of the plate 410, gamma mb 1.25, the partial safety factor. If you substitute, you will get the bearing strength as 74.78 kilonewton. Then therefore the bolt value is equal to 29 kilonewton, and number of bolts required to provide is equal to load he has given 150 kilonewton in the question. 150 divided by what is, okay, I think here it is not, this is 150 divided by 29. Okay, please make the correction. 150 divided by 29, you have got how much? 5.2. Means now here you need to provide how many bolts? 6 bolts. And this is the diagram along the 3 lines. Okay, there you provide how many bolts? 6 bolts. Okay, this is how we need to represent by the diagram. Then if you come to the second one, single core butt joint. As if once again single core butt joint, here also means it is having what is the your single, the shear failure is only one single shear failure, hence your the design strength due to shear will remain same, but only thing is your bearing strength, okay, it may change. Okay, because here your T is equal to what? Your T is equal to 10 mm. Okay, because out of two plates you need to take what is the lesser value. Okay, I think rest of the thing it will remain same. You got this as what is 59.83 kilonewton. Out of these two values, lowest value is 29 kilonewton. And here you got it, the number of bolts is what is 6 bolts. And this is the representation how we have done. Similarly for double cover butt joint, okay, as it is double cover butt joint, normally it will fail by what is the double shape. Hence here I have taken the NNS2, NSS4, NSS0, sorry. Okay, hence your, since the two plates of thickness 18 mm and 10 mm are to be joined, the packing plate of thickness 8 minus 18, 18 minus 10, 8 mm will be provided. Now here what he is telling, as there are two plates, okay, one plate is 18 mm but other plate is how much? Okay, other plate is, this is how much? 10 mm. Okay, and this difference, whatever this difference is there, okay, this difference they have to fill by water, they have to fill by the your the packing plate, that is equal to what? 18 minus 10, 8 mm. And as per I told that whenever the packing plate thickness is more than 6 mm, okay, as per clause number 10.3.3, okay, we need to reduce the shear capacity. And if you want to reduce, you calculate this beta pkg is equal to 1 minus 0.0125 TPKG. TPKG means the thickness of packing plate. Thickness of packing plate is how much? 8 mm. Okay, if you substitute this, you will get what is 0.9. And we need to reduce the shear strength by 0.9. This is shear strength formula. Here Nn is equal to 2. Okay, but this, the entire thing, you need to multiply what is beta p kg. Beta p kg, 0.9. This is the strength of the bolt in shape. And similarly, you can calculate strength of the bolt in a bearing. Okay, and you will go how much? 74.78 kilonewton. And out of these two values, the lowest value is bolt value 52.2 R. And hence the number of bolts is equal to how much? 4 bolts. In this way, you can design your the bolted connection. And this is representation. I told that here the one plate is there, here one plate is there, and this is the this actual portion is called what is packing plate, and the top this and this are what is the cover plates. Okay, this is how we have to represent this connections. Next, if you come to the welded connection, two plates of thickness 16 mm and 12 mm are to be connected by a groove weld of effective length 150 mm. There are two plates, one is 16, other one is 12 mm. They are to be connected with an effective length of the weld, how much? 150 mm. The joint is subjected to a factor tensile force of 300 kilonewton. Those two plates, that joint is subjected to what? 300 kilonewton. Check the safety for single V-groove joint and double V-groove joint. Assume Fe410, the grade steel plates, and the welds are shock welded. This is what he has given. Okay, now we'll do separately for single V and also what is double V. First, he has given the thickness of the plates are what? 16 mm. Means we have taken TP, the lower thickness of the plate. One is 16 mm, other one is what is 12 mm. The thickness of thinner plate. Okay, the thickness of the thinner plate is equal to what? 12 mm. And Fu is 410 as well. Gamma MW, factor of safety due to welding, is what 1.25. And I already told, whenever the single groove butt weld is there, it is what the incomplete penetration. From your IS code, throat thickness is equal to 5 by 8 times of thickness of thinner plate. Okay, 5 by 8 times of thinner plate is 12 mm. Okay, this is how much? 7.5 mm. This is what your T, throat thickness. Length of the weld is given, and we know the formula: Fu divided by square root of 3 comma mw multiplied by lw into lt. The same formula what you have seen in the previous slide, same thing you have taken, but the form is in another way, but entire thing is same. LW has given T we know, Fu we know, root 3 we know, gamma we know. T means throat thickness, this 7.5 mm. If you substitute all these values, you will get this as how much? 213.04 kilonewton. And as there the applied force is 300, hence the 213.04 kilonewton is less than what? 300 kilonewton. Hence it is what? The applied load is 300 kilonewton, but the resistance of joint is, the strength of the weld is how much? The strength of the weld is 230. Okay, hence it is what? Unsafe. Okay, it is not safe because strength of the weld is 230, but the applied load is 300. Hence it is, the joint is what? Unsafe. And similarly, if you calculate for double V joint, the throat thickness is equal to minimum thickness of the weld metal. Okay, and out of those two plates, thickness is what? The lower thickness is 12 mm. LW as well, same formula. If you use, you will get this as 340. Hence it is greater than 300 kilonewton. Hence it is safe. Okay, in this way you can solve what is the welded connections. Okay, with this I will make full stop on this, the revision session of model number 2. Okay, if you have any doubts, please ask. Thank you for watching.